Okay, so what we just talked about were called complementary events. It is the opposite of an event happening. So the probability of the event happening plus the probability of the event not happening should always equal 1. Okay. So the easiest way to find it is to take 1 minus the probability of the event happening, and that will give you the probability of the event not happening. So that's what we're going to do with each one of these. What is the probability a boy is not called out of class? First off, 1 minus. We know the probability of a boy being called out of class. What is the probability of a boy being called out of class?
1/7. I mean, no, not one. Yeah.
12 out of 27. Okay. So 12 out of 27 is the probability of a boy being called out, which means the probability of not a boy is 1 minus that.
Huh? Oh, yeah.
Oh. Change it to a fraction. 15 over 27, which is 5 over 9. It reduces down. Okay. So to find the probability of something not happening, we take 1 minus the probability of something happening. So 1 minus. We want to find the probability that a student doesn't have blue eyes. What's the probability that a student has blue eyes? 150. Somebody give me a grand total for all that.
That's stupid.
I'm doing it right now.
That's
72.
Seven-
600.
What? 72,600.
No, I said
Should be 600.
because I was adding.
Okay.
I was talking out loud.
So 1 minus the probability of having blue eyes should give me the probability of not having blue eyes.
Wait, can you?
3/4. It actually comes out to be 450 out of 600, which is, you said 1/4?
3/4.
3/4. 3/4, sorry. Again, your calculator reduces the fractions for you. Example 3. If a number from 0 to 999 is called out loud, what is the probability that the number will contain at least 1 3? So we need 1 minus the probability of no 3s. How do I find the probability of no 3s? If I want absolutely no 3s, how many options do I have for a number? How many digits do you have total? 10. If I take away the choice of a 3, how many options do I have? 9. And it's a 3-digit number, so it's raised to the third. Over, I technically have 10 digits available, raised to the third. Okay, so at least 1 3 is 3 or more. This is no 3s. So that's actually 1 minus, no, that's not 271, that's 8, no, 7, 9, 729 out of 1,000. Okay. So you actually get 271 out of 1,000. I had 271 chances of having 1 3 in my number, whether it be in the first position, the second position, or the last position. This one here, instead of doing 1 minus 150, I could have added 285, 93, 72, and gotten 450 out of 600. Okay, this is just a different way to come up with the same answer. Okay, couple more and we are done for today. Oh, this takes us back to 15.3.
I need Zeph to the main office.
Okay. Are you leaving me?
Bye.
Okay. last sections, we left off on counting theory. Consider a random example of tossing a fair coin 4 times. What's the total number of possible coin flip combinations? Are they telling you that you can't repeat? No, so I can repeat. Multiplication rule. So, if I'm flipping a coin, what options do I have? Heads and tails, which is how many options? 2. How many times am I flipping it?
2.
4.
Hey, dude, chill.
Okay, so this gives me what? 16. This is your total sample space. AKA your denominator. For everything as we go. Okay, you always have a total of 16 choices. Okay, that's everything included. What's the probability of getting exactly 1 head? Again, does it tell me where the head has to go? No. So is that permutation or combination?
Permutation.
Combination.
Combination.
Okay, exactly 1 head. How many times am I flipping my coin?
16.
4. How many heads do I want?
1.
1 out of 16. That's why you do part A.
Someone needed to go.
I was listening. Sure. Lacey.
Just give us a thumbs up.
Say hi to YouTube. Uh-huh. Oh, you're fine. We're good.
Fractional decimal. Doing fractional decimal.
No.
It doesn't matter.
No.
Okay? You get 1/4 or it's a decimal 0.25. Okay? C. What's the probability of getting at least 1 head? What does that mean? At least 1 head.
1.
At least
Oh,
So 1,
2,
2,
3,
3,
4.
and 4. Why do I stop at 4?
Because
I'm only doing it 4 times. So, remember, I need to have 1 head, so 4C1. Or, I need to have 2.
42.
Or, I need to have 3. Or, I need to have 4. Again, all over 16. Because that's your total. So we don't do part A just for the heck of it. That helps us with everything else. Because now we're talking probability. Last chapter, we just talked about how to find this number. Now we've thrown in probability. So we have to divide by your total amount. Hit equals. Now divided by 16.
Is it 1.5?
1.5
15 over 16.
should never be above 1.
For me.
Probability should never be over 1. When you plug this into your calculator,
Oh,
you're going to
yeah.
need to plug in this top part and hit equals and then divide by 16. Okay. You want the easier way to do that?
Please no.
At least 1 head. Is 1 head, 2 head, 3 head, or 4 head? What's the opposite of that? What does that not include? 0. So 1 minus the probability of getting nothing or no heads. Your complement. Your complement's a lot shorter than adding 1 plus 2 plus 3 plus 4.
Give it away.
So we can do 1 minus the complement, and guess what? You still get 15 out of 16.
Mr. Smith, I have a request. Can you always tell us the easier part first? Not gonna be hard. Like the walls.
No, because you didn't grasp any of the concept of what I did before, so no.
Bro, give me glasses.
Okay, so you've got 2 different options to attack this. If you don't like complement because it doesn't make any sense to you, don't use it. You can do this way. This way is just a little bit longer. Just a little. Okay. How many possible answer keys exist if I have a 16-question true-false test? Again, it's options raised to the questions. How many options do I have if I'm doing a true-false test? 2. How many questions? 6. So I have a total of how many possibilities? 64. Okay. I want exactly 3 truths. How do I write that? Always the total first. Total question. 6. C. How many exact do I want? 3. Divided by 64.
Easy. Do we have like to enter these, or we can just set it up like?
No, you need to answer these.
Answer 5/16.
5/16. If you left it as a decimal, it's 0.3125. Okay. Unless it tells you on the test, I want a fraction here or I want a decimal. I don't care which way you give it to me. Okay. Probability of having at most 2 falses. So, what does this mean? At most 2 falses.
16.
You can't have any more than 2. So that's 2, 1, or 0. Okay. So 6C, I want 2. Or 6C, I want 1. Or 6C, I want none. All over 64. Again, you have to plug this in and hit equals and then divide by 64. Or if you want to plug it all in at once, toss that top part into the set of parentheses before you plug it in. I don't see you plugging in anything into your calculator, so don't sit here and go cricket, cricket,
I'm
cricket
just saying.
when you have a calculator in front of you.
Okay.
Oh, no, that's because I did something else.
You got what?
11.
I got 11/32.
Oh, I'm in 32.
Okay. I got 11/32. Okay, or 0.34375. Now, before you start plugging in this big, huge equation here, probability of an answer key having at least 3 falses. What does that mean? More than 3. So 3, 4, 5, or 6. What is this compared to that? The opposite or the complement. So guess what? I can do 1 minus 11/32 to get this answer and shortcut myself. Or you could have done 6C3 plus 6C4 plus 6C5 plus 6C6
Okay.
all over 64.
So those are the 2 options, right?
You get 21 out of 32.
6 by 55.
Or 65625. You got it. In this section, all answers, when you're doing probabilities, should be between 0 and 1. So you should always either have 0, 1, or a fraction or decimal in between. Okay, we good.
4 characters.
4-character password is made up from numbers and letters, which are case sensitive. How many possible passwords are possible? How many options do I have for each space of my password? We're case sensitive. 62. I have 10 numbers and I have 52 letters, which are case sensitive. So I have 62 options in each space of my password. How many spaces do I need to fill? 4. Let's leave it like that. So you don't have to type in all these numbers. You can just write 62 to the 4th. What? 52 letters because we're case sensitive, which means your lowercase and uppercase are different. Okay? So we've got double of what you have. Probability that a password will use no even digits. If I take away even digits from 62, how many options do I have? How many even digits do I have between 0 and 9? 5. 0, 2, 4, 6, and 8. If I take 5 away from 62, how many options do I have? 57. So 57, and I'm filling in 4, so 57 to the 4th divided by 62 to the 4th. That's much easier to type in than if you would take 62 and raise it to the 4th. 0.714, we'll stop there. Okay, my password has to start with a number and end with a number. So how many options do I have here? It starts with a number, 10. It ends with a number, 10. These can be either number or letter, so each one of these is, again, divided by the total possible, 62 to the 4th. 0.026. Probability that a password will use only lowercase letters. Every spot has to be a lowercase letter. How many options do I have? 26. How many spaces am I filling with those letters? 4. Divided by the total, which is 62 to the 4th. You said 0.03. 0.031. Because remember that 9 rounds that 0 up to a 1. What do you think? Stop there for today?
Yes.
Sounds like a plan to me, my friends.
How many balls do we got in the homework?
So the back of the page will be 5.
Okay.